Jacob, it's great to have you here. I think a lot of people are excited to attend today and just kind of talk with you and hear about what you're working on. I'll leave you to do an introduction, and then we can kind of talk through the system which you and I have been collaborating on, ask some questions about that, and then just go into conversation. And I'm sure other people have questions they want to ask you too. But yeah, where are you coming from? What have you been doing? What's your background?
Yeah, for sure. So hi, everyone. My name is Jacob Tsafatinos. I'm currently working as a staff engineer at a company called Elemi. The company focuses on trying to make healthcare better for kids with autism. And right now, the work that I'm doing there is mostly like a big migration from like a V1 MVP version of the stack onto a V2. I've been there for about maybe like 5 or 6 months. But previously, and the stuff that we'll be talking about today, I was working at Uber for a while, and there I was working on the Uber ads team, where I built out the whole like event processing system for everything related to ad events. So it would be things like counting clicks and impressions, doing ad attribution, like so when an ad, things like attribution. So when an ad comes through or an order happens on Uber Eats, how do we know that an ad was responsible for it? Something like that, and then taking that data and distributing it across various different like data syncs so that they can be accessible to different customers who need that data. So one example would be putting it into like a data warehouse so that data scientists could access it. Another one would be putting it into like a OLAP analytical type storage so that we could use it for dashboarding to like show the ad success. And another destination would be like a Kafka topic for other services to consume. That was like the majority of my time at Uber. Before that, I was also working at Shopify on some like machine learning pipelines, and before that, I was at Amazon for a few years.
Exciting stuff. So tell us, I think to start, what's really interesting would be to hear what you're doing at Elemi. So Elemi kind of delivers personalized support to kids with disorders like autism. And what does that look like on a day-to-day, and how does the data engineering you've been doing come into that?
Yeah, honestly, it doesn't come in that handy, to be honest, because the priority of what we're working on is essentially this company was built in a way that was really over-engineered for what they needed. It's built in like, ironically, like in an event processing or event-driven type system, but in reality, it's a very simple app that really does not need a lot of like over-engineering, and simplicity and moving fast is a much bigger priority. So a lot of the shift is actually to simplify most of this, putting things into like a backend that isn't like a crazy microservice system, like converting things to a monorepo. Typically, as you get more experience in different companies, I've worked on companies at different scales, the typical flow is going from like a monorepo to microservices, because at some point, like a monorepo doesn't scale up enough unless you do it in a very specific way. So it's been interesting to work in the reverse, where it's like we're going from microservices over to a monorepo type thing.
That's funny.
The data engineering, I would say, comes in more handy, but just like in terms of like how we think about data and because that's another piece that you always have to think about this when you're building things from scratch as well. Like who's going to consume this data? What form does it need to be in? There's a lot of like unclean data or data that's like unstructured. So for example, even like there's an input form, and it could be something like the child's age, and they take it in as like a string, which means it could be like the word 6, the number 6. It could be represented like 5.5 if it's like 5.5 years, or literally a combination of both, like 5 and a half years, and it could be like 5 as like a number. So things like that if you're not thinking about data as you're building things and who the consumers of it are, you might take for granted like how you build something, and then you're in a much worse shape to actually leverage that data when you need it for things like marketing or doing analysis or trying to make data-driven decisions for like product. Things like that. So part of the revamp is creating a completely new data model with more strict restrictions on like what certain fields can be, and stuff like that.
Cool, good stuff. I think, you mentioned one thing there I'd really like to dig into later, which is the experience you've had across working companies at different scale. Obviously, like Uber is like super massive scale, and here this sounds like something slightly different, and I wonder what other experience has been like in the past. But yeah, I think we should dive into the system that we've been working on and kind of show people that, and then we can get into questions. I know myself and Yvonne had some questions. I'm sure the others will too. I'm going to pull up that video, which we've seen before. the introduction of ads in Uber Eats, the engineering team at Uber needed a way to ingest data from two separate sources: events generated by ads and orders made through the app. But if Uber can't link ads to actual orders, they can't understand their impact. That's why the Uber engineering team developed this system. It's designed to ingest data from different sources and find matches between the ad events and the corresponding order. Ad clicks come into Kafka. And are sent to Apache Flink, where the data is aggregated and cleaned. The events are also stored in a Hive data warehouse for later use. Then, each event is tagged with a unique ID. Later in the pipeline, this will be used to remove duplicates, which would otherwise produce incorrect metrics. It's so important that these metrics are correct, because they're served to businesses that depend on them to understand ad performance, to Uber's data science teams to monitor the health of the system, and to Uber's billing system, which is used to charge the business's advertising. If an ad click is attributed to any order any more than exactly once, then the metrics will be incorrect. Doing this is called exactly once semantics, and it's the key technical challenge that this system addresses at scale. The point of this system is to do the complicated task of linking ads to orders and process those events only once to serve accurate metrics. Next, Flink aggregates the events into buckets by minute. A minute is large enough for being reliable, but not too large that it would fill the database too quickly. The aggregated data goes to DocStore, a highly scalable data store. At the same time, the data goes to another Kafka sink. The sink ingests the ad data from the Flink job and data from the businesses serving ads. Here, we have the data which tells us who interacted with what ad. We call this the attributed ad event data. The whole system operates across two regions. Replicas of each component run in each region, and data is balanced between them. This provides a more resilient system, since if one of the regions fail, the other region can still ingest the data. While all this happens, restaurants are receiving orders. The order events are ingested in this system from a Kafka topic, and then matched with the events in DocStore using the user ID. The events generated from the ads have to be attributed to the corresponding order, so the data from these orders are compared with the ad data that was previously sent to DocStore. If there's a match, then we can attribute the order to the ad events, and in that case, the UUID generated earlier is attributed to this order. These attributed orders are sent to a Kafka sink. Then they're merged with the aggregated ad events by a Flink job. This Flink job can also receive information from the other region to improve robustness. This data goes to Hive, so it can be used to derive insights from later. And the data stored in the Pione database can be used to quickly provide dashboards so users can query different metrics to measure the performance of the business. This impressive data pipeline enables Uber to serve valuable metrics to businesses based on huge amounts of data from totally separated sources, reliably, accurately, and in near real time.
Yeah, it's kind of a lot. It's hard. It's a little bit hard to distill down into a few sentences, but essentially what you can imagine is we needed, the whole purpose of the system is to process ad events in a way that is fast, reliable, and accurate, and to do that across a distributed system, which is a very hard problem to solve. There's a few things that to do that it requires. One is to have the semantics of exactly once. In stream processing, especially, there's like a concept of like at least once. There's one other one and then exactly once, but essentially like exactly once ensures that you're never reprocessing an event twice. And so there's the challenge of doing that across even things like a distributed system across like data centers is difficult. So what this system does, on the surface, it's not too complicated. Like it's a few different Flink jobs, which do some basic like filter, mapping, reduce type operations, and maybe like a little bit of data hydration. But to do that in a way that achieves all of our requirements is where we have like fault tolerance. So like if a job fails for some reason, like maybe it reaches out to an external service to get some extra data that it needs, but that call fails and that causes the job to restart. How do we make sure we don't reprocess the same event more than once, or that we don't commit it before we have it in the state that we need? Those are the types of things that make this system a lot more complicated. Does that make sense?
Makes sense to me, but I've spent significantly more time studying than other people. If anyone does have questions, just feel free to join in and ask away. But I guess, what's the business importance of the exactly once?
Yeah, so the business importance, the reason why we need reliability here, or at least, and it's a mix of reliability and accuracy, is that ad events represent dollars. So if someone clicks on an ad, there's literally like a dollar amount associated with that, probably like somewhere in the cents. But every click, that's how we end up charging customers. So when we process that click, we need to aggregate that data and say like, okay, this many clicks happened, and we need to expose that to like a budget service, like somewhere that can actually charge a merchant for that. There's some other implications of it as well. So number one, like exactly once is important so that we don't overcharge or undercharge the merchant. Like we need to make sure that like we are charging them exactly for what they've paid for, and nothing more, nothing less, right? Otherwise, it would lead to a pretty bad customer experience. Another piece of it is also on the pacing side of things. So within like an ad system, there's a whole bunch of other systems that ad systems are comprised of. There's like the budgeting system to charge merchants. There's a concept of pacing. So to explain this, you can imagine someone wants to run an ad campaign with $100 budget. Let's say they tell us they want to do that over a week. There's probably enough real estate on the app to just spend that entire budget in like an hour if we really wanted to. But with any like ad system, you have this concept of pacing, which means just like pacing that ad over like the lifespan of its schedule. And to do that, you also need to know like how many ads we're engaged with, or how many like ad events we're engaged with. So okay, we've already displayed this ad X many times. We probably shouldn't display it again for the rest of the day, something like that. So that's another piece where like if we don't have it being reliable, and we've had like some of our failure cases are when the whole system goes down for like an hour, and then we end up overspending what we should have spent, or we over-delivered ads for that restaurant because the system was down and we didn't have that like feedback to get that feedback to say like, hey, we served X amount of ads. Those are like some of like the bigger issues. Overall, then there's also just like customer trust, right? Like when we want to report the performance of an ad, if a customer wants to know like, hey, was this worth my money? Like, did I make more money? With Uber, it's a little bit trickier than like your typical ad system. Right, like for Facebook, attribution is really hard. If I sell stuff, especially if I'm a restaurant and I want to do like a Facebook ad, it's almost impossible for me to know like how many customers I got from that ad. Like, how do you know how many people walked into your restaurant from that ad, or how many people went on to like Foodora or DoorDash or Uber Eats to order for you? But on Uber Eats, like there's no like gray zone attribution to hide behind. It's like if a restaurant gives us money for ads, they better see that they made more money off that ad than they spent, or at least they broke even and they got like new customers because of it who might order from them again in the future, right? Yeah. So those are some like, so for customer trust, like we need to be pretty accurate with our reporting to make sure that like, we are telling an accurate story of like, this is the value of the ad that you ran.
Mm-hmm. Yeah. So when you and I spoke, we've realized that we'd made kind of one technical misunderstanding, one pretty major one at least, wasn't it? And that was that we thought that the system was trying to attribute events off from other platforms, so advertising on say Facebook ads or something like that, and then bringing them into Uber, and that would have been a much harder problem, you said to us. But in this system, we're actually kind of we're all within the Uber ecosystem, so we know when people are on the Uber Eats app. And then you create an ID which is deterministic based on the order, timestamp, and some other things, so that it's pretty easy to identify in the other part of the system. Is that right?
Yeah, the ID is used for the ID is an important piece, and it's used for different pieces of it. One piece being that like, so the exactly once mechanism of this is like pretty crucial to the system to run in accurately, like we've been talking about. But the way for it to do that, it essentially uses, I don't know if you're familiar with the concept of like transactions or transactional rights. but the whole system has to kind of write messages in this transactional way, meaning that like our Flink jobs, when they're done processing the events, they would write that data to like a Kafka topic, for example. But that Kafka topic wouldn't consider it written until there's like a confirmation that like this has been committed and done. And then anything consuming from that Kafka topic also has to consume it transactionally. And that ID, that deterministic ID helps is something that we can use for those transactional commits. Another piece of it is not everything in the system is exactly once, like using exactly once semantics. We kind of fake it in some ways. Like we still get the same result, but for example, one of our output destinations is like this like Hive table, like a big like data warehouse. And unfortunately, like there's no good way to write to that table exactly like only once. So there's a lot of duplicate records, but we're able to deduplicate them when we read them based on this deterministic ID, because that same ID will get generated no matter how many times we process those events.
Yeah.
So that's how we like still get exactly one semantics, despite maybe not the entire piece of it being exactly once.
Yeah. Maybe I think it would be helpful for everybody if I share my screen and I'll just kind of point out the UML diagram here to kind of signpost some of the things that we're talking about. So we've talked about over here in this aggregation, this is where the ads come in, the events on the ads come in, and that's where we give them this deterministic ID, isn't it? And over here, you're talking about the final upsert where we store the ad metrics in the Pione database. That's not actually exactly once, but you just kind of, you either update an existing entry with the same information because it's an upsert rather than actually process it again. So over here, we're not doing exactly once, but over here is where we are. And that's because we're trying to get to the attributed order events down here, which we don't want to over or under calculate.
Yeah, that's a good summary. I would say like the two data stores, like here you see Hive and Pione, both of them are leveraging the unique identifier in different ways. Pione uses Upsurf, so we're either overwriting it or not replacing. Like we're just updating the entry, and then Hive we're just duplicating everything. Like we're just writing whatever we get to Hive. But Hive is like the only customers of our Hive tables are data scientists, and anyone on our team knows that like, okay, if I'm going to query this table, I need to make sure that I'm deduplicating on this specific key, which you can do in your queries to Hive. So that's not really a big deal. Mm-hmm. And Hive is like long-term storage, so the extra records is not that big of a deal. In the same way that it would probably be a bigger deal in like Pione. And then you're right, like the rest of the system leverages exactly one semantics, meaning that like it's only committing things transactionally. Mm-hmm. So like we'll only ever write one message once to the Kafka topic and the aggregated events Kafka topic, and then any clients consuming from that topic will also consume them transactionally, making it so that they only ever consume them once.
And as far as I understand, that exactly once is actually pretty simple. It's just settings configured in Kafka. Am I right? Or is there a lot more complicated stuff to it?
No, it is pretty much the settings configured in both Flink and Kafka. Mm-hmm. Like in some configurations, the slightly trickier part is just making sure that like your Kafka consumers, because like to say something is exactly once, it's not enough to just say that like Flink and Kafka are using exactly once. Any consumer of that data has to also be consuming it exactly once. So if you have a Kafka consumer, like our systems are written in Go, so our Go Kafka consumers have to be updated to also consume them exactly once. Mm-hmm.
So I guess just we keep talking about Kafka just in case anybody is not totally familiar with what that is. It's a distributed message queue. So you can essentially send messages to Kafka with a producer. They go into some storage in the middle called a topic, and then different services can read from them using consumers. So for example, this Flink job would be a consumer of this Kafka topic where the data is stored, and this Flink would have a producer which puts that data into Kafka. So the way my understanding of this system is that it really breaks down to like three parts, right? And the first one is the aggregation. So what exactly is going on with the aggregation, Jacob? What's the point of, I think it's sort of this region of the UML diagram?
Yeah, so the aggregation is mostly just to count events. It's pretty simple. We get a bunch of clicks and impressions, and we just need to know how many there are. And we want to do it. The reason why we aggregated it is we don't want to overload like our dependent services just with like raw events. Like in theory, I guess you wouldn't even need this aggregation if depending on like how well you could scale up your other systems, but it wouldn't scale for very long. So for example, we chunk these into like minute windows during the aggregation. which is not that bad for like, if you call like a service once a minute, it's not that big of a deal. But if we just did it for every raw ad event that came in, that could overload not only like the services that depend on this information, but also like our downstream databases. Probably not Hive. Hive is used to storing raw events, but like our Pinot table, for example, would probably grow in size to a point that is like way too big too quickly.
So that's what you actually mean by aggregation, isn't it? It's like it's like aggregating everything that happened within 1 minute into kind of summary metrics, which are then passed on. And just so you don't have, I guess it could be, I don't know, what scale are we talking? Like what kind of scale do the events come in? Is this thousands of events a second? Is it more?
Yeah, I mean, so we built this up from scratch. So at the time when I was working there, I can't remember exactly. But like in terms of like dollars or scale, like I know ads at Uber Eats made something like $200 million plus last year. And I think like this year, I'm sure their goal is to make something like $1 billion. So like the system has to scale up like and for that to scale, like essentially it just means like more of ad events are happening, right?
Yeah.
So you can imagine like we needed to support the scale of whatever $200 million a year is, plus like future growth of like next year is going to be $1 billion. Then year after that, I'm sure will be like $3 billion. Whatever aggressive goals they have, like this thing needs to scale with time.
Insane. And Uber, I know, is running some of the largest Kafka setups of any company, I think, right? Could you talk about that for a sec? Just like what's the scale there?
Yeah, I mean that's like even way beyond ads, or like you can imagine ads is probably like a subset of mobile traffic for a variety of reasons. Like rides, for example, is a much bigger app than Uber Eats. Like way more people use Uber. Well, typically and historically that was true. Or a lot. I don't know if that's necessarily true today, given like the pandemic and everything. But for sure, like ride data, most of that stuff goes through Kafka, and one of the reasons they use this is. There's a bunch of reasons, but like the data engineering team, for example, has like a ton of experience, and they contribute a lot to like open source Kafka, open source Flink, open source Pinot, and Kafka is at Uber is like the choice messaging queue and way that we kind of orchestrate our systems. A lot of it is around passing messages between Kafka topics and stuff like that.
Can you give us any numbers on that? Like, do you know like how many servers are in the Kafka cluster, or how many events are being processed for any?
Honestly, I have no idea. I'm sure it's like some of the most in the world. I know they've like published blogs about it, and I'm sure there's like numbers there. But I don't know off the top of my head.
Hell of a lot, basically.
Yeah, way more than whatever this system is. I'll tell you that. Like, probably like an order of magnitude way bigger than whatever we're ever going to process in ads. Uber is doing for like ride data.
Yeah. So I said there's kind of the three parts which I'm thinking of, right? The first is the aggregation, so just summarizing kind of what happened to what ads in certain aggregated bunches of time, and then you've got the attribution. So talk us like how are these things linked, and what's the point of this part down here? Attribution, what's link?
So I mean they're linked more. More in like the aggregation isn't really linked to attribution, in that what part of the aggregation job, like in theory, we probably should have split out the aggregation job into two jobs. There should be one job first that is like data cleansing, validation, maybe fraud detection, something like that, because we do all that in the aggregation job. But we probably should do that first, and then at that point we write the raw events to this doc store before we aggregate them. And the reason why we store these raw events is so that we can use them later for attribution. So one of the benefits of Uber being like one of the biggest Kafka deployments is that as a consumer of data, if there's a Kafka topic that you're interested in, you can kind of just consume from it if you need. And so one of those things is like order events. Like I didn't have to touch order events at all. There's just like already a team that deals with order data, and they write their data to this Kafka topic, and I can become a consumer of it. So for me, like I can, what I do here in the attribution job is I just consume every order that goes through Uber's Eats system, and then I try to see like, is there an associated ad event in our doc store table? And if there is, great. That means we can do an attribution, because it means that like we only store those ad events for a certain amount of time, like at whatever our attribution window is. And it means that like, hey, like we do it based on like who the user is and who the restaurant is, right? So if we see like, oh, there's a click event in our database for this user and for this restaurant before the order happened, then we can say, okay, this is because of an ad. So it's not that complicated in terms of like doing the actual attribution.
Mm-hmm. Cool. But so what we're doing here is we're linking essentially what happened on the ads to orders, checking that they match, come up with some data which represents that attributed order events. And then the thing over here, I guess the final part of it is the union. And so that's just what's going on there.
That one is just to like standardize the data before it goes into our goes into our databases essentially. So we consume data from the aggregate ad events and our attributed order events. And then there's like another piece here that is a little bit more complicated to get into, but this entire system, I think we talked about in the video, but it's replicated across two regions, region A, region B. And the way that our Pinot tables are set up is in an active way, meaning that they don't talk to each other to stay in sync. So we need to and because our data is like replicated across regions, we need to make sure that we grab all the data that's that like gets produced from the other region and write to like both tables. So this union job, you can imagine it's like it exists in both regions, and in both regions it's kind of consuming from like there's like an X, like it's consuming from the other region to replicate that data into like our Pinot cluster.
Mm-hmm. Cool. Yeah. So we've got these two different regions and sharing data across them to make it much more robust, right?
Yeah, and there's some more nuances here that are like a bit harder to explain, but essentially like Uber also has this concept like within Kafka. We have like aggregate Kafka clusters and local Kafka clusters. And aggregate clusters, what that means is that so if you have a Kafka topic and you have it's called like mobile ad events, for example. You'll have at least three different versions of that Kafka topic. You'll have like region A mobile ad events, region B mobile ad events, and aggregate mobile ad events. So if you don't care about like having things be regionalized, you can just read from the aggregate one, because eventually it'll be like eventually consistent, and all the data will eventually make its way to the aggregate one from both sides. Mm-hmm. But there's some nuances in the system. I think aggregate topics at Uber are a little bit more of like more important in that that aggregate cluster that operates like the aggregate Kafka topics is harder to change, and the exactly one semantics had never been used at Uber before our system, so we needed to enable that, and the team was not comfortable with us enabling it in like the aggregate cluster, so we opted to do it in the local clusters, and so that's kind of why this last Flink job exists. It's a little convoluted, and there's a lot of little nuanced reasons that have more to do with like the internal limitations that we had at like Uber with our data engineering teams and stuff like that.
Yeah, it's infinite depth of complexity, it seems. Yeah. It's funny looking at this and thinking about it now. There's like different levels of these crazy networks going on, because you've obviously got this system here. The diagram itself is a big network of different systems. Then within Kafka and Flink, I believe, then we've got these huge distributed systems of many different servers all communicating together. And then you've got the same system in a different region. And then you've got the fact that these Kafka topics are not just used for this system, but they're also pulled on from and contributed to by loads of other systems in the Uber ecosystem. So it's just kind of it's a marvel to see just the scale of it, really, and how huge it has to be all networked together.
Yeah, and when you like the longer you work too, or like the bigger places you work, there's a lot of like sometimes when you're an engineer, you think like, oh, I can just design the best system based on like what the best technology is out there. That's not really like a real accurate representation. There's always these limitations of like, what can your company support? Do you have the right resourcing in terms of like people? And that can come down to like a variety of things, like even like what language do you choose to write your thing in? Is you just do the one the company already does, or do you use the best language for the job? How many people on your team have experience with that language? How many people have to ramp up with it? There might be things that are better suited to solve the problem, but then the realities of like your organizational structure always come into play, and you always have to like work around these other constraints that aren't necessarily just like what is the optimal solution for this from like a pure tech standpoint.
Other than the different Kafka clusters, the what did you call them? Was it aggregate and
aggregate and then local, like the local
aggregate
ones.
And local Kafka cluster? Was there any other kind of key examples of the challenges you faced from a kind of organizational perspective when you were working on this?
Yeah, for sure. I think one of them was, so one thing was the Upsurf feature, for example.
This is something I wanted to get into, actually. Yeah.
That feature, number one, didn't exist before we started. Like it was in production while we were starting our work. And I had luckily like one of the staff engineers in Uber's data engineering team was actively working to like push that to open source Pinot. That's one of the benefits of working with a lot of open source technology is you can get those benefits from other people pushing features. But that was an example where like I had to work closely with that staff engineer to time things out appropriately to make sure that like that feature was ready for when we would need it. And then we could like implement these things and test it. We must have been one of the first users of that feature because like the second he put it out, we were like testing with it already. So there's things like that. There was a lot of coordination there. Also on top of that, the feature didn't necessarily work the way that it was advertised, not because there was anything wrong with the Upsurf feature, but there's like a nuance in that the way that it works is it essentially like if you're going to upsert on a specific key, like on a primary key in your Kafka topic, that message always has to go to the same partition, Kafka partition. So to explain this for anyone who doesn't have context, the way you scale up Kafka typically is you have one queue, but then you create more partitions. Like essentially you're replicating that same queue across multiple partitions. And you can do that like for as many as you can handle. And so the way that this feature works is you need a Kafka partitioner, which means when a message is getting written to Kafka, there is some logic that will say like, okay, this message goes to this partition. And that can be done in a variety of ways. You could just do it randomly if you don't really care. Like you could say like, oh, just like round robin, like first go to number 1, then 2, then 3, then 4, then 5. Or you can have some logic that like takes in the key and hashes it and then decides like, okay, this key will always go to this partition. And so that team's partitioner logic was broken. So like I had to literally like go in and work with that team to like figure out where was the mistake, which partitioner should we use, and we ended up having to make like some code changes to that partitioner to fix it. But that's like definitely another example of like some organizational pain points where it's just like, yeah, you have to work with a bunch of other people across different teams to get these things working.
Yeah, and I think good examples there of just, you know, the real world engineering is it seems to be a lot of the time certainly not writing things from scratch, but going and taking something that already exists in some form and then having that, I guess, kind of, you know, engineering attitude to adapt it to what you needed to do. So like you didn't go and say, oh, Pinot doesn't have an Upsurf feature, we're gonna have to create our own system. You went and contributed to that, or you didn't say, oh, you know, this other part of Uber is doing something which doesn't work, we'll build our own. But instead you kind of have that attitude of, you know, just collaborating and making it into what you want. I think that's really cool.
Yeah, I definitely say that like as you get more and more senior, the differential becomes less and less like your coding ability or like your specific like implementation skills. A lot of the differences come out in terms of like more soft skills, like leadership type things. Like, can you collaborate well with other people? Are you good to work with in certain ways? And like, can you get things done in the right way so that you're not duplicating effort? Like a big problem at Uber, I remember, less so when I was there, but initially, a lot of people were just replicating the same system across multiple, because they just like were not talking to each other. The company's so big and distributed across like the world in different offices, and there was a lot of replication of virtually very similar things, and that's a huge problem because engineers are very expensive, and you're potentially wasting like millions of dollars across teams to build the same thing that another team is doing. So like having that awareness, having that those communication skills, making sure that like people are aligned, and doing it in a way that is like makes those teams want to work with you, because like you can also just like go around barking, being like, I need this done tomorrow, and then like nobody wants to work with you and they're not going to do it and your project's going to fail, right? But you're doing it in a way that where like, you know, I'm jumping on a call with that team to go through their code. I'm not just like, go fix it, you guys broke it, it's your fault, you know? Like you doing it in a way that demonstrates some like good ownership and collaboration is that, I think that definitely will take you farther in your career.
Mm-hmm. Any kind of, you know, key points of advice, maybe tangible things that people could take away to kind of play to that more?
Yeah, I would say just like don't be afraid to ask questions, but when you ask questions, make sure you do your due diligence. So like never go into like a Slack thread and just say like, hey, this is broken, Like that's not really useful. Like but if you say like, hey, this is broken, these are the troubleshooting steps I took. I looked into like the console output, I looked into logs, I did like, here's my attempt at doing it. And if like I would say like 90% of the time, if you just do those things, you're going to solve the problem yourself anyway. But then when you can't solve the problem, it shows that you've like put in more effort to like actually try to debug what's going on. So that's kind of, I would say like you can be like a good collaborator in a lot of ways. That's like for especially more junior people, that's my biggest advice. Is just like don't ask a lot of questions, but make sure you've done at least some front work to make sure you're not just like wasting someone's time for something you could have looked up yourself.
Yeah, that is so brilliant and so useful, because everybody here listening knows about the support request feature, and now you see exactly what we're talking about when we ask you, please, leave as much detail in the support requests before you raise them. Try and actually have a look yourself, Google it, ask your friends, and see if they can help. So thanks for fighting my side, Jacob, and not making us have to go and deal with issues which are just like, it's broken.
Yeah. Well, it'll just help you too, because like you'll learn a lot from when you do debug things yourself. That's another thing that you don't realize is like the act of figuring things out for yourself helps you a lot to grow quickly, a lot faster than if someone just like gives you the answer. A good example of this is I also run like a Git workshop, and the reason why I started this workshop is because I kept solving the same issues over and over again for people. Sometimes literally the exact same issue that I helped someone with like a week before, and they just got into the same thing. So they clearly weren't paying attention. So instead of like helping people like reactively when they run into issues, I decided to make a workshop, and like every intern, for the most part while I was there, I don't know if they're still doing it, but virtually every intern that came through Uber would go through my workshop. Most junior people would go through my workshop, and we would do this to make sure that like I did that somewhat selfishly, but also because I wanted to like level up everyone. And I used to be like that intern who didn't know what was going on with Git and freaked out and would ask the same stupid question or just go to like Stack Overflow constantly. And then make things worse for myself. So I was like, if we can like upfront that work, it's do like a proper workshop to like teach people even some like basic troubleshooting skills on like how they can solve this themselves, then I think that'll go a long way.
Yeah, that's awesome. And yeah, I know exactly how you feel. Cool. I mean, to kind of get through this system, then like at the end, a few different people use it. Yeah. So who's using Hive? Who's using the Pione database? Who are the clients over here, and what are the different things those people want to get from the system?
Yeah, so Hive, it's typically data scientists for the most part. Maybe some operational people if they're like sophisticated in querying, they can use that to like report directly to there's some white glove service. It's not always dashboarding, but like McDonald's isn't going to log into their like Uber Eats dashboard. They want like a face-to-face with someone who's going to just like present them their metrics. So Hive and Pione like could be ops, but Hive primarily is serving data scientists who are running like experiments and want to see like the outcome of their experiments. Pione is mostly for reporting for like the actual advertisers themselves. They log into a dashboard. They click something like show me the past performance for the past like week, or give me the return on my ad spend, or how many clicks I got over like the past month, stuff like that. All that good stuff, like all those queries go to Pione. And then our clients are like other ad services, like I said, like a budget service that needs to charge customers for the ads, or like a pacing type system, or really anyone who's interested in that data.
Yeah. And what about the clients?
Like those are the clients. Like those would be like a client. When I say client, I mean like another service internally. So something like the budget service, where that one just consumes all the events and then it like charges. It like has a process to actually charge a merchant. Or like the pacing system that is like constantly updating itself to make sure that it's distributing ads accordingly.
Got you. Awesome. So yeah, I think kind of cool example there of how this quite hardcore data engineering system is really at the heart of the data science process, of where the experiment results kind of come out here. Data scientists change things, which is how ads are shown to users over here. It has to go through this data engineering pipeline, and the same for even just the business operations itself. So it's really at the heart of it. That's awesome.
Yeah.
Nice, cool. Anything else we haven't covered on here you think's worth mentioning, Jacob? Otherwise we can go into some other stuff.
No, I think that's the majority of the system.
Cool. Well, let's wrap up talking about that system then. I've lost my Zoom. Yeah, and I had a few questions I wanted to ask you, kind of, around that and unrelated that. First, I wanted to ask you. I wanted to ask you to tell us about Good Kid.
Yeah, so Good Kid is my band. I play in a indie rock band called Good Kid. Everyone in my band is actually like a programmer. Our singer is actually the founder of a company called Cohere that just got on a New York Times article, which is sweet. But yeah, our drummer works at like some like satellite company. I think our bassist is currently at Snapchat, and our other guy works at Ticketmaster. But yeah, we're a band of programmers. We're doing pretty decent right now. About to go on a tour in the States, in like the East Coast. So if anyone's in those cities, definitely hit it up. Yeah.
That's awesome. Double life.
Yeah, it's a little bit of a double life. It's a little bit hard to manage sometimes, but it's been super rewarding to do both. And it's interesting. It's interesting to like, I mean, I've been in band my whole life, and this is definitely the most successful band, but it's been interestingly, like they're both career, obviously, like the longer you work, the theoretically, like the better it gets. But both career and band are kind of like growing in the same point. So I wonder if eventually there'll be like some inflection point where we have to decide which one to pursue. Yeah, Good Kid Official. That's the one. Heron.
Nice. Cool. Back to the
like
thing.
Spotify and everything. If you wanna check us out.
Wicked. Yeah, definitely will do. We'll share that later. Back to what I mentioned at the beginning. Could you talk about the different places you've worked and what what kind of person you think fits best into each of different cultures? Because you worked at, if the order's right, I think it was Amazon, then Shopify, then Uber, now LME, right?
Yeah. It's a good question. Amazon is a good place to get your ass kicked and like level up very quickly. It's not the best culture, I'll be honest. Like I didn't enjoy a lot of my time there. I had not a great relationship with my manager. It's a very antagonistic culture. In that like it's like, some people say some places are like blameless. Amazon is very blame focused. Like what happened? Why did it happen? Whose fault is it? Things like that. And they put a lot of pressure on people in a way that I don't necessarily think is great. But I was there for like 2.5 years. I did learn a ton. It definitely leveled me up as far as being an engineer, like probably a lot faster than I would have at another place. And I did have a really good manager for like a short period of time. And when she was my manager, maybe like 7 months. While she was my manager, I think I grew more in those like 6-7 months working at Amazon than I did the entire like remainder of that time under like the manager I didn't particularly enjoy.
What did she do so well?
She was just great at like giving feedback. Like her feedback was meaningful. It was well thought out, and her suggestions for how to improve things were really like she clearly cared. The other guy like would give feedback, but it was like, so a good example of this is like I would be on call one time, and when you're on call, you get patient about a bunch of things. And he in the morning when we had like our team stand up, he asked me to do something, but it was pretty risky. So I wanted to make sure that I like did my due diligence, made sure that like this wasn't going to go wrong, or if it did go wrong, I had a plan in place to like how I would fix it. So I spent like an extra couple of hours like just making sure that I had that in place. And then I ended up doing the thing he wanted in like the afternoon. And if, of course, something went wrong, but I was able to fix it up like almost immediately. And the feedback, I got an email from him at the end of the day being like, I'm very disappointed in you. When I ask you to do something, I expect you to do it immediately. Something stupid like that. And I was like, what? I was like, and I like, at that point, I was like, I think that was the point where I decided I was going to quit after that one. But that was like just kind of an example of like this type of things he did where he clearly had no idea. Instead of like asking me like, hey, why did this take an extra couple of hours? Were you, assuming good intent or something? He always kind of assumed the worst. And then also that's useless feedback. Like it doesn't like do something when I ask you. If I had done it when he asked me, it would have been so much worse because I wouldn't have had the plan to roll back like immediately and how it would solve the issue, Whereas like my other manager, if she were to say the same thing, she would say like, hey, here's a way how you can speed up this process in the future. Or maybe here's some like upfront work or some coordination we could have done earlier to make sure that when I ask you next time to do something fast, we can execute it on it like very quickly, instead of like putting so much like this again, like the difference is like blame. This guy was very blame focused, like it seems like he always wanted like a scapegoat or something. I don't know. It was just a really toxic culture. So Amazon, I would say if you can put up with the bullshit, definitely a place where you can learn a lot and grow quickly. And not gonna lie, it helps to have Amazon or a place like that on your resume, just because like it's Amazon, it has a good reputation and people will reach out to you forever. Even when I was working at Shopify, I would get recruiters reaching out to me all the time, and they would never even mention Shopify. They would just be like, "Oh, I saw you worked at Amazon," And Shopify at that time was like the biggest Canadian company, pretty much. So it still didn't really get the same respect. that Amazon got. And then yeah, so I would say like that's the kind of person who can do well at Amazon. And I'm sure like there's other experiences. Like I have other friends who had better or worse. Like some people had way worse experiences than I did at Amazon. Some people had way better and love it and are still there like 6-7 years later. So every team is different, but my personal experience I think is more in line with like what the average experience is, which is this kind of like middling antagonistic type experience. So Shopify was kind of the polar opposite. Very great culture, really, really, really strong and like people first kind of culture. But the engineering culture was not really there in the same way as it is at Amazon. Like their attention to detail, operational excellence, just like standards were a lot worse. So Shopify has this thing where they say like when you get hired, they're like everyone here like 10x's and gets so much better. And I'm sure that's true of a lot of people. But having come from like the team I was on at Amazon, I felt like I regressed a lot while I was there, or not regressed, but I didn't feel like I grew much while I was there. And so I think after about a year and a half of that, when I was like doing some reflecting and saying like, looking at like, oh, like am I growing in the way that I want to grow as an engineer? And is this like the kind of culture and place that can support that? Not so much. So I think Shopify is a good place for someone who just like, if you just like, maybe you're not super passionate about engineering, but you like the job and you want to like work in a really good place that will treat you very well, and you can like do good work and still have fun, but maybe not really push the boundaries of a lot. Like I would say Shopify is a great place for that. And then with Uber, I didn't even actually want the job at Uber initially, because when I took the interview, I was honestly, I don't know if I should say this, but I was trying to get a free trip to New York because like they were interviewing people in New York, and I'm from Toronto, and so sometimes companies will like fly you out to interview you, at least back then before like the remote culture was so strong. And then they like last second switched it on me and they're like, oh, actually we're starting a Toronto office. And I was like, okay, well, I'm already this far in the process. I might as well do the interview. And yeah, there's a lot of warning signs of Uber. Like they had a bad reputation at the time, like culturally they had like all those allegations from like Susan Fowler, if you don't know, but a lot of like harassment issues. But they had like said they had cleaned up their reputation and they fired their old CEO and a lot of the old executives, like everyone, they kind of cleaned house. But I was just so impressed by the people who interviewed me that when I like, even though I had no intention of going there, when I started interviewing, when I left that interview, I was like, oh shit, I think this could be the perfect mix of what I want between like Shopify and Amazon, where like really, really strong engineering culture, but hopefully much better like personal culture. And honestly, what I found was like that was like the good mix. Like Uber is a place where I would say like the engineering culture might not be as extreme as Amazon, like probably slightly worse, but still very, very, very strong and very good.
And that was what impressed you, was it the technical expertise of the people who were interviewing you over?
Yeah, it was just like the types of questions they asked and like the back and forth that we had, and when I asked questions, like how they answered them and how they thought of problems and stuff like that. I just like it made me think like I could definitely learn from these people.
Yeah.
So I think Uber is like a good mix where like it's definitely not as like kumbaya as like Shopify is. Probably not as like rigorous. They move a lot faster than Amazon, and so definitely not as rigorous in terms of like you're learning like engineering fundamentals and how to build things like in literally the most robust ways ever, but still very good engineering culture and a good like personal work culture. Like I had a great time at Uber. So I would say if you're looking for that like more balanced type of thing, like that's a good place for you. And then LME is like really small startup. Most of these things are not defined, like engineering culture, personal culture. Like most of that stuff is, I would even say like I'm 5-6 months in yet. I don't really have a good grasp of like what they are because it changes so fast. But I would say this is probably true of every startup. And when you join a startup, like it's probably a better place for someone who is like more okay with the chaos and things changing and not having them be defined and things like literally changing like constantly. And there's nothing wrong with that. It's just like a different like kind of personality and what you sign up for.
And so I think kind of one thing that would be useful to ask you here would be, how did you get into your first software engineering roles? Because that's where a lot of us are coming from. Or maybe, kind of earlier in the career. You were a software engineer before Amazon as well, weren't you? How did you get to there, and how did you get into Amazon, I guess? Yeah,
I did a couple of internships before Amazon. The way I got those internships, which is probably the hardest one, is honestly one of them, I just like literally applied to every place I could. I sat down one day with a friend of mine and we applied maybe to like, we made like a template. I don't know if this works too much anymore, but we made like a template email.
It doesn't work that well.
What?
It doesn't work that well. We've seen a lot of examples.
I imagine, but I went for quantity over quality, and I probably emailed like 1,000 places, and then one got back to me, and that one was this startup in Toronto called Wave Accounting, and you only really need one. So in my opinion, like that's how I was looking at it.
Mm-hmm.
But I mean, you only need one, and then you need to get the job. So luckily, like I interviewed well enough to get it. Yeah. So that's kind of how I started there. I had another internship, which was kind of like random. I don't really remember exactly, but I think it was a similar story. It was like a very, very, very small place, like 3 people. And I just like applied and had an interview, and luckily it went well. But there's a lot of like, from like not just my experience, but friends' experiences to get that first job. There's a lot of like unconventional first jobs you can get. Like there's a lot of like research labs that are associated with universities or something that need programmers to do some like pretty entry level stuff. It's not always like big tech company that needs like an intern or something like that. There's so many, like a lot of my friends got their start at like literally like a healthcare research lab that's associated with like one of the hospitals in downtown Toronto, and they don't pay very well, but you get like experience, and that's how a lot of them got their start. And then when I got like Amazon, I think I had a friend who worked there, so I just like asked for a referral, and then I just got batched in with like a huge batch hiring event. There was like, I think they flew like 50 of us down to Seattle, and they interviewed everyone in that like time, and it was a little bit intimidating, and I almost like didn't show up because I thought like I definitely wasn't going to get it, but then I just like showed up, and luckily I interviewed well enough, and I got it, but it was a little bit random. I've also had weird experiences with, like, I wouldn't say referrals. Like, referrals are good, and if you could find someone to work somewhere that's willing to refer you, that's great. I will say most people are willing to refer people because it's a really good market, and you get a referral bonus as an engineer. So, like, for me, if I refer someone to Amazon, if they get hired, I'll get like $2,000 or something like that. And so, like, I refer most people who reach out as long as I think that they have a chance of getting that job.
Yeah.
But there's good ways to reach out and not. But yeah, that one I just kind of got lucky. Got a referral, and referrals don't always go through. I referred a friend once, and they didn't even get reached out to for like 8 months. So it's a bit of like hit or miss there too. But I think I just got a little lucky in the beginning.
Yeah. And so, you know, I don't think any of your roles have actually been data engineer, right? But you are clearly, you know, doing all of the responsibilities of some data engineers, or maybe not. Tell us about that. What do you think you're missing, or?
I'm somewhere in the middle, I would say. Like, I'm definitely more like building applications on top of data engineering work. But there's not a lot of people who do that in general. Like, even the team I was on at Shopify, we were doing like machine learning pipelines, a recommendation system to like feed data from like feature data that we had from like shop data into like these TensorFlow like machine learning models, and that was very data. Like, I think I've just like happened to work in very data focused type projects. Whereas, and that kind of like makes me interact very closely with data engineering teams because I have like, that's essentially, those are just the problems I'm solving. It's not like a typical, here's a backend service. We need to just make like some APIs that we can expose and people can get like certain information. Like it's always the projects that just happen to land on are these types of projects. It's weird because I don't even like necessarily seek them out. It just kind of happened that way.
How would you differentiate software engineering from data engineering as a role then?
I would say it's like something like that, like what I was saying, like your role when you're doing more data engineering stuff is really thinking about like how data is getting from like point A to point B, and doing it in ways that are efficient, accurate, things like that. Depending on the company that you're working on, data engineering can sometimes be like literally you're the team who is operating this stuff at scale. So like at Uber, for example, there's a team that owns Kafka. So if there's an issue with like a Kafka cluster, the data engineering team is like on it, trying to figure out what that issue is, you know? Or like I was mentioning, there was a team that I had to work with to fix a bug in the Kafka partitioner. The team that wrote that Kafka partitioner is like part of the data engineering org. Like they wrote that initial partitioner. And typically, ideally, they're doing it in a way where I can just use it and not think about it. But again, like, because like my work was so closely like somewhere between that line of data engineering and just like regular like backend engineering, I like literally will dive into the code and see. It's honestly not like, they're not like worlds apart, I would say. You know, like if you're a software engineer, you can probably understand the majority of like the data engineering work. Like I can go in and I can read what a partitioner is. It's just logic being like event comes in, some decision logic of like how do we decide which partition it goes to, and then and then it like writes to that partition. It's not crazy like complicated. There's more obviously complicated work within that field, but there's definitely a lot of overlap too.
Yeah, because I think a lot of us are kind of here considering, okay, I know I want to do some form of, I want to work in the AI and data stack. Do I want to do data engineering, software engineering, data science, machine learning engineering, infrastructure engineering, and all that kind of thing? So I wonder, could you give us maybe some, what would be the most typical scenarios for someone in data engineering that might give everybody here a good example of what that might look like on a day-to-day?
Yeah. So something like that would be, well, there's a few, again, it's like pretty broad, but one thing would be, so if people here are familiar with like Spark, for example, I know like Shopify had like a data engineering team for a product called Starscream, which is like their like wrapper around Spark. And what that is essentially they will operate Spark at scale for a company like Shopify, and then they'll expose a bunch of features on top of it, maybe some like additive features that are unique to the Shopify use case, giving you easy connectors between maybe like Kafka and Spark or things like that type of work to make it so that it's easier for people to leverage. Sometimes your work is a lot more closely related to like data scientists, for example. Like if you're a data engineer, you might be supporting a data science team, and maybe there's like a lot of data goes to a certain database, and you might be working on the query engine that they use to be able to query that data in a way that is efficient. And then you, as a data engineer, you're also maybe concerned with like, how does this data get partitioned? How do we scale this up so that as we get more data in, the queries don't slow down to a halt and the data scientists can continue to do their work, in a way that is fast. Like that's a good example. Like that's something that my girlfriend kind of works on at Shopify. She's a data engineer there. So that's a good example. Or again, like in the case with Uber and Pione, the guy who contributed like the Upsurf feature to Pione is a data engineer, and he's like a staff engineer in the data engineering org. So it's kind of just like I would say like the main difference I see it is like thinking about like who your customers are. And when you're a data engineer, your customers are typically like data scientists or other engineers, less so like a product or like a customer, like a outward facing customer or something,